सर रेकॉर्ड केलेले ह्या ऍप वरच दिसणार का?
हा दिसेल तुम्हाला लेक्चर. आता फक्त समजून घ्या, मग नंतर मी सांगतो. लेक्चरची लिंक पण देईन तुम्हाला. तर आपण आता लेक्चर सुरू करूया. थोडस कंडिशनल प्रोबॅबिलिटी काय आहे परत एकदा रिवाइज करतो. प्रोबॅबिलिटी ऑफ ए गिवन बी, म्हणजे फॉर गिवन इव्हेंट वी हॅव टू फाइंड द प्रोबॅबिलिटी ऑफ ए. म्हणजे बी काहीतरी दिलेले इव्हेंट आहे, फॉर दॅट वी हॅव टू फाइंड प्रोबॅबिलिटी ऑफ ए, अँड फॉर्म्युला फॉर दॅट इट इज प्रोबॅबिलिटी ऑफ ए इंटरसेक्शन बी डिवाइडेड बाय प्रोबॅबिलिटी ऑफ बी, where probability of b is greater than 0, not equal to 0, greater than 0. So this is a formula for conditional probability. And theorem 1 given that a be any event defined on omega, a be any event defined on omega, then conditional probability satisfies all axioms of probability. The first axiom is conditional probability lies between 0 to 1 for all A and B. Second axiom, that is probability of omega given A is equal to 1, and third is probability of B union C given A is the same as probability of B given A plus probability of C given A, where B and C are mutually exclusive in, that is B intersection C is equal to 5, that is, this is condition, and for that this is happening. Probability of B union C given A is equal to probability of B given A plus probability of C given A. So here we have given that B and C are mutually exclusive, and A may be have intersection with B and C. So here Venn diagram, आपल्याला इथे Venn diagram काय आहे, तर हा A आहे, हा B आहे आणि हा C आहे. तर B आणि C हे दोघं म्युच्युअली एक्सक्लुसिव्ह आहेत, म्हणजे B आणि C हे म्युच्युअली एक्सक्लुसिव्ह आहेत. हा B आहे, हा C आहे आणि हा A आहे. A चं दोघांबरोबर इंटरसेक्शन आहे, परंतु B आणि C हा म्युच्युअली एक्सक्लुसिव्ह आहेत. अशा पद्धतीची वेन डायग्राम आहे. तर आपण हे सॉल्व्ह करूया. ते तिन्ही एक्झाम प्रूव्ह होतात हे दाखवूया. प्रोबॅबिलिटी ऑफ B गिवन ए. आता प्रोबॅबिलिटी ऑफ B गिवन A is equal to probability of A intersection B plus probability of divided by probability of A. We know that every probability is positive. Therefore, probability of B given A is a positive since by axiom 1. Axiom 1 of probability by using axiomatic definition. We know that A intersection B is a subset of A. A intersection B is a subset of A. Means A intersection B is a smaller set than A. So probability of A intersection B is a less than or equal to probability of A, implies probability of A intersection B divided by probability of A less than or equal to 1. So probability of B given A, and this is nothing but probability of B given A less than or equal to 1. So here we have probability of B given A is greater than or equal to 0, and probability of B given A is less than or equal to 1. Combining both these, म्हणजे आपण हे कंबाईन केले तर काय मिळणार आपल्याला, प्रोबॅबिलिटी ऑफ बी गिवन ए ही शून्यापेक्षा मोठी आहे पण 1 पेक्षा लहान आहे. म्हणजे प्रोबॅबिलिटी ऑफ conditional probability also lies between 0 and 1. This is axiom 1. Now we will go to axiom 2. So axiom 2 is probability of omega given A. So probability of omega given A, omega intersection A divided by probability of A, and omega intersection A. Omega is a sample space and A is any set belongs to omega. But A हा त्याच्यातच आहे omega मध्ये. So their intersection is A. So probability of A upon probability of A is equal to 1. So this is second axiom. We have proved that probability of omega given A is equal to 1. And last one, probability of B union C given A, which is equal to probability of B intersection C, B union C intersection A divided by probability of A. So by using distributive law, we have distributive law वापरला तर काय मिळेल, probability of B intersection A union C intersection A divided by probability of. So probability of B intersection A and probability of C intersection A, these are mutually exclusive. इथं आपण बघितलं तर हा बी इंटरसेक्शन ए आहे, हा ए इंटरसेक्शन सी आहे, हे दोन्ही म्युच्युअली एक्सक्लुसिव्ह आहेत. सो बाय युझिंग एक्झाम 3 वी हॅव प्रोबॅबिलिटी ऑफ बी इंटरसेक्शन ए प्लस प्रोबॅबिलिटी ऑफ सी इंटरसेक्शन divided by probability of A by axiom 3. Axiom 3 of probability, we have probability of A union B is equal to probability of A plus probability of B provided A and B are mutually exclusive. हे दोन्ही mutually exclusive are. So this is nothing but probability of B intersection A divided by probability of A plus probability of A intersection C divided by probability of A, and this is nothing but probability of B given A plus probability of C given A, and that we have to prove. So conditional probability also follows axioms of probability. So this is a theorem that we have seen. The conditional probability satisfies all axioms of probability. Now we are going to see another example. A and B be two events defined on omega. Let A and B be two events defined on omega. That is, they are belongs to omega. Then we have probability of A and probability of B are positive. They are greater than 0. Then probability of A given A complement is equal to 0. If A and B are mutually exclusive, if A and B are mutually exclusive, then probability of A intersection B, probability of A given B is equal to 0. If B is a subset of A, B is a subset of A, then probability of A given B is equal to 1. And if A is a subset of B, then probability of A given B is equal to probability of A divided by probability of B. That we have to prove. So we have to prove these 4 theorems or 4 problems. तर आपण सुरुवात करूया probability of A given A complement. So probability of A given A complement is equal to probability of A intersection A complement divided by probability of A complement. So we know that A and A complement have not intersection. That is, if this is A, then remaining part is A complement. That is, this part is A complement. So there is no intersection between A and A complement. A and A complement मध्ये intersection नाहीये. So this is a phi set, probability of phi divided by probability of A complement, and probability of impossible set is 0, 0 divided by something is 0. So this probability is 0. Now we are proving if A and B are mutually exclusive, A and B are mutually exclusive event, mutually exclusive events. If A and B are mutually exclusive, that is A intersection B is equal to phi. If A and B are mutually exclusive, then A intersection B is equal to phi, implies probability of A given B. Probability of A given B is equal to probability of A intersection B divided by probability of B, and probability of A intersection B, that is probability of impossible set, is 0. So 0 divided by something is 0. That is a second part of this example. We have proved that if A and B are mutually exclusive, then probability of A given B is equal to 0. Similarly, probability of B given A is also equal to 0. Since probability of A intersection B is 0 in both cases, दोन्ही केसेस मध्ये A intersection B ची probability 0 आहे. तर हे अशा पद्धतीने हे एक्झाम्पल आहे. तिसरा पार्ट आपल्याला बघायचा आहे. तिसरा पार्ट असा आहे, if a B is a subset of A, B is a subset of A, then probability of A given B is equal to probability of A intersection B divided by probability of. आणि जर आपण बघितलं तर probability of A intersection B. So here the case is B is a subset of A. B is a subset of A. म्हणजे B हा A मध्ये B contains in A. So A intersection B, that is B, only B, because A contains B. So probability of B divided by probability of B, and this is equal to 1. So this is a probability of A given B. If A is a subset of B, then probability of A given B is equal to probability of A intersection B divided by probability of B. आता A हा B मध्ये, here in this case A is contained in B. So here A intersection B is equal to probability of A divided by probability of B, and this is a probability of A given B in that case. So this is a, in this case, त्याच्यानंतर आपण बघणार आहे probability of A complement given B is equal to 1 minus probability of A given B. So as we have probability of A complement is equal to 1 minus probability of A, त्याचप्रमाणे probability of A complement given B असले तरी पण तोच थेरम लागू राहतो, फक्त conditional probability, condition फक्त given B चे. So how to prove that? Probability of A complement given B is equal to probability of A complement intersection B divided by probability of B. A complement intersection B, so probability of A complement intersection B is, so here A, here B, A complement intersection B. A complement intersection B is this case, this part. A complement intersection B. So probability of this event is equal to probability of B minus probability of A intersection B. We have seen in probability chapter first, that is probability of A complement intersection B is equal to probability of B minus probability of A intersection B divided by probability of B. Now we will divide separately probability of B divided by probability of B minus probability of A intersection B divided by probability of B. So this is a probability of B upon probability of B. This is equal to 1 and this is equal to A given B. So this is equal to 1 minus probability of A given B, probability of A complement. Hence the proof. Are there any doubts? काही doubts आहेत का? जर काही doubts नसतील तर आपण पुढे जाणार आहे. Are there any doubts regarding this event? सगळ्यांना समजलंय? तर आपण आता ऍडिशन थेरम बघणार आहे. ऍडिशन थेरम आपल्याला माहिती आहे. सो ऍडिशन थेरम इज probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. For unconditional case. For unconditional case. So in case of conditional probability, it is probability of A union C given B is equal to probability of A given B plus probability of C given B minus probability of A intersection C given B. A intersection C given B. So याच्यासारखाच आहे, but the condition is present in all cases. Now we have to prove this theorem, addition theorem for conditional probability. Consider probability of A union C given B. A union C given B is equal to probability of, so this is equal to A union C intersection B divided by probability of B. So this is equal to probability of A intersection B union B intersection C divided by probability of B. by using distributive law. Intersection distribute over union. मग आपल्याला हे मिळालंय. मग प्रोबॅबिलिटी ऑफ ए युनियन बी चा फॉर्म्युला आपल्याकडे आहे. प्रोबॅबिलिटी ऑफ ए प्लस प्रोबॅबिलिटी ऑफ बी मायनस प्रोबॅबिलिटी ऑफ ए इंटरसेक्शन बी. By using this formula, we have probability of A intersection B plus probability of B intersection C. Probability of A plus probability of B minus probability of intersection of these events. So this is nothing but probability of A intersection B intersection C divided by probability of B. A intersection B intersection with B intersection C. So what did we get? So if this is A, B, C, A, B, and C. So A intersection B intersection with B intersection C, though this is a intersection B intersection C. Here the intersection. So this is A intersection B. This is a B intersection C, and the common part is A intersection B intersection C. So this is equal to probability of A intersection B divided by probability of A plus probability of B, sorry. Probability of B intersection C divided by probability of B minus probability of A intersection C intersection B divided by probability of B. So by using definition of conditional probability, this is equal to probability of A given B. This is equal to probability of C given B. Since probability of B is in the denominator, so it is given minus probability of A intersection C given B, and hence we have the addition theorem. Addition theorem सुद्धा या केस मध्ये आपल्याला मिळून जातो. So काही डाउट्स आहेत का याच्यात? Are there any doubts? डाउट्स असतील तर मला विचारा. तर काही डाऊट नसतील तर मग आपण पुढे जाऊया. आपण आता पुढे बघणार आहे कंपॅरिझन बिटवीन अनकंडिशनल अँड कंडिशनल प्रोबॅबिलिटी. कंपॅरिझन ऑफ कंडिशनल अँड अनकंडिशनल प्रोबॅबिलिटी. Comparison of conditional and unconditional probability. So if A and B are mutually exclusive event, A and B are mutually exclusive, and that is A intersection B is equal to phi. In that case, probability of A given B and probability of B given A both are equal to 0. But probability of A is positive and probability of B is also positive. So what we have in this case? Probability of A given B is a less than or equal to probability of A. The probability of A given B is equal to 0. This is equal to 0, but probability of A can be greater 0 or greater than or equal to 0. So this is a less than or equal to case. So here in this case strictly less than, because probability of A, if we consider in this case probability of A given B, so in that case probability of B should be positive. Probability of A can be anything greater than or equal to 0. In that case this equality holds. So if A and B are mutually exclusive, and that is A intersection B is equal to phi, in that case probability of A intersection B is less than or equal to probability of A. That is unconditional probability is greater than conditional probability. Second part, if A is a subset of B, then we have seen that if A is a subset of B, in that case probability of A given B is equal to probability of A intersection B divided by probability of B, and this is equal to probability of A. A is a probability of A intersection B is equal to A divided by probability of B. And probability of A is a positive, and this is also greater than or equal to 0. In this case, probability of A is divided by some number. So in that case, probability of A given B is a greater than or equal to probability of A. कारण आता आपण नंबर बघताना फ्रॅक्शन आहे. Here probability of B is lies between 0 and 1. So this is a fraction, and fraction by fraction is positive greater than probability of A. When we are dividing by fraction, that number is greater than that number. So this is in that case, if this case, and if B is a subset of A, if B is a subset of A, then probability is equal to probability of B divided by probability of B, and this is equal to 1. And we know that probability of A is less than or equal to 1. In that case, actually probability of any event lies between 0 and 1. So probability of A is less than or equal to probability of A given B in this case. So unconditional probability is less than conditional probability when B is a subset of A. And last one, A intersection B not equal to phi. So there is set A intersection B. This is not impossible set, or this is not empty set. In that case, probability of A given B is equal to probability of A intersection B divided by probability of B. So this may or may not bigger than A. Bigger than. So we can't say in this case, if this is case A intersection B is not equal to phi, then in this case probability of A given B may or may not be bigger than probability of, that is, we can't say about anything about their inequality, that is conditional probability is greater or unconditional probability is greater. In this case we can't say anything. When A intersection B is not equal to phi itself, the probability of A given B, ची probability of A पेक्षा लहान असू शकते किंवा मोठी असू शकते, we can't say anything. So these are the theorems, and now we are going to see some of the examples. आपल्याला काही examples बघायचे. So first example is probability of A is equal to 0.4. Probability of B is equal to 0.3. And probability of A union B is equal to 0.5. So we have to find probability of A given B. We have to find probability of A given B. आता आपल्याला probability of A given B काढायची या केस मध्ये. तर आपल्याला माहिती आहे probability of A given B साठी आपल्याला probability of A intersection B माहिती पाहिजे. So formula for probability of A given B is probability of A intersection B divided by probability of B. So आपल्याकडे probability of A intersection B is not given. A intersection B is not given. So in that case, by using addition theorem, probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. By using addition theorem, we have this. So probability of A given A union B is 0.5, 0.4 plus 0.3 minus probability of A intersection. So probability of A intersection B काय असणार आहे 0.7. So probability of A intersection B इकडे आला, हे 0.5 तिकडे गेलं, वजा 0.5 which is equal to 0.2. So probability of A intersection B is 0.2. Now we can write 0.2 divided by probability of B is 0.3. So this is nothing but 2 by 3. म्हणजे आपल्याला सगळे मागचे थेरम इथं वापरावे लागतात. तर एक्झाम्पल मध्ये काय डाऊट, इज देअर एनी डाऊट्स इन दिस एक्झाम्पल? अनम्यूट करून तुम्ही विचारू शकता. इफ देअर आर नो डाऊट्स यू कॅन गो फर्दर. आता पुढचं एक्झाम्पल असं आहे बघा. Probability of A is equal to 0.4. Probability of B is equal to 0.3. Now we have to find probability of A complement given B complement. Given A and B are mutually exclusive. We have given A and B are mutually exclusive events. If A and B are mutually exclusive, then probability of A intersection B is equal to 5. This we have given. So now we will see probability of A complement given B complement. So this is nothing but by using definition, probability of A complement intersection B complement divided by probability of B complement. तर आपल्याला आता probability of B complement A complement intersection B complement काढायचंय. Probability of A complement intersection B complement is equal to probability of A union B complement by using De Morgan's law. De Morgan's law काय सांगतो? Complement is same as A union B complement. This is nothing but probability. So this is nothing but probability of A union B, probability of B minus probability of A intersection B. So this is nothing but 1 minus. So 1 minus probability of A we have given 0.4 plus 0.3 minus 0. Probability of A intersection B is 0 since A and B are mutually exclusive events. So this is nothing but 1 minus 0.7. This is equal to 0.3. This is equal to 0.3. So 0.3 divided by probability of B complement. Probability of B complement can be given by 1 minus probability of B, and 1 minus 0.3 is 0.7. So 0.3 divided by 0.7, this is nothing but 3 by 7. So this is required probability of A complement in given B complement. म्हणजे आपल्याला इथे डी मॉर्गन्स लॉ वापरावा लागला. नंतर एक थेरम वापरला, probability of A complement is equal to 1 minus probability of A. That is probability of A union B complement is 1 minus probability of A union B. And by using these theorems, we have proved or we have calculated probability of A complement given B complement. तर अशा पद्धतीचे आपल्याला एक्झाम्पल्स असतील परीक्षेला. काही डाऊट्स आहेत का या एक्झाम्पल्स मध्ये? असतील तर विचारा. आपण आता एक एक्झाम्पल बघू वाटल्यास. A pair of dice is rolled. Find the probability that. आता pair of dice is rolled. So we have dice टाकलेले आहेत, pair of dice. म्हणजे काय काय मिळणार आहे आपल्याला? 1 1 1 2 1 6 2 1 2 2 2 6 up to 6 1 6 6. So we have 36 outcomes. When we are rolling a pair of dice, we have 36 outcomes. So we have to calculate the probability that probability A, sum of the numbers on face 8, sum of the number on face is 8. Given that number on first die greater than number on second die, greater than number on second die. So probability of A given B. So B contains, आता B मध्ये काय काय एलिमेंट आहे? number on first die greater than number on second die. So what will be the element? आता 1 1 याच्यात इक्वल आहे, चालणार नाही, ग्रेटर दॅन पाहिजे. नंबर ऑन फर्स्ट आहे ग्रेटर दॅन. आता इथं सगळीकडे 1 आहे विच इज लेस दॅन ऑल द नंबर. सो नंबर ऑन फर्स्ट डाय ग्रेटर दॅन नंबर ऑन सेकंड डाय हे चालणार याच्यासाठी. मग काय चालणार? 2 1. पहिला आपला एलिमेंट आला 2 1. आता 2 याच्यात येणार नाहीत, कारण 2 इज अ नॉट ग्रेटर दॅन ऑल द एलिमेंट्स इन दॅट रो. नंतर आपण कुठं जाऊ शकतो, 3-1, 3-2, 3 येणार नाही, त्याच्या पुढचं येणार नाही. नंबर ऑन फर्स्ट डाय ग्रेटर दॅन सेकंड डाय. नंतर काय होणार, 4-1, 4-2, 4-3. नंतर 4-4 चालणार आहे, कारण नंबर ऑन फर्स्ट डाय सेम ॲज नंबर ऑन सेकंड आहे, त्याच्या पुढे चालणार नाही. मग कोण चालणार पुढं, 5-1, 5-2, 5-3, 5-4. आणि आपल्याला 5-4 पर्यंत चालणार आहे, 5-5 चालणार नाही. तसंच सिमिलरली 6-1, 6-2 अप टू 6-5, 6-3, 6-4, 6-5, 6-3, 6-4, 6-5. तर आपल्याला आता ए इंटरसेक्शन बी मध्ये आता आपण जर बघितलं तर आपला सॅम्पल स्पेस प्रोबॅबिलिटी ऑफ ए गिवन बी, तर सॅम्पल स्पेस एवढा झालेला आहे, बी एवढा झालेला आहे. आता बी मध्ये किती एलिमेंट्स आहेत टोटल, बी मध्ये किती एलिमेंट्स आहेत टोटल, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. देर आर टोटल 50. म्हणजे आपल्याकडे बी मध्ये 15 एलिमेंट्स आहेत. आता त्याच्यातले असे किती पॉइंट आहेत की ज्याच्यात सम इज 8. आता याच्यात किती आहेत, द नंबर सम इज 8. आता सम इज 8 म्हणलं तर आपल्याला काय चालणार आहे, 5-3 चालतोय, नंतर कोण चालतोय, 6-2. देर आर ओनली 2 नंबर्स विच सम इज इक्वल टू 8, 5-3 and 6-2. So this is equal to 2/50. So this is equal to 2/50. हा झाला आपला डायरेक्ट बघायचा अँगल. कारण कंडिशनल प्रोबॅबिलिटी मध्ये, इन केस ऑफ कंडिशनल प्रोबॅबिलिटी, द सॅम्पल स्पेस रिस्ट्रिक्टेड टू गिवन कंडिशन. सॅम्पल स्पेस कमी होतोय, तर इथे रिस्ट्रिक्ट झाला बी एवढाच. बाय डेफिनेशन जायचं म्हणलं तर प्रोबॅबिलिटी ऑफ ए इंटरसेक्शन बी डिवायडेड बाय प्रोबॅबिलिटी ऑफ बी. सो बाय युझिंग डेफिनेशन काय करू शकतो आपण, प्रोबॅबिलिटी ऑफ ए इंटरसेक्शन बी. आता ए म्हणजे काय आहे, नंबरची सम 8 असली पाहिजे. तर पहिल्या रो मध्ये कोणच नाहीये, 1-6 पर्यंत कोण नाहीये. दुसऱ्या रो मध्ये येणार आहे 2-6, नंतर कोण येणार आहे 3-5, नंतर कोण येणार आहे 4-4, 6-2 आणि 5-3. हे आपल्याकडे एवढे एलिमेंट्स येणार आहेत. मग जर आपण बघितलं तर प्रोबॅबिलिटी ऑफ ए इंटरसेक्शन बी, आता ए आणि बी मध्ये कॉमन कोण आहे, ए आणि बी मध्ये टोटल 2 एलिमेंट्स आर कॉमन. सो बाय युझिंग probability of A intersection B is nothing but 2/36. M upon N, that is number of favorable cases. Favorable cases A intersection B साठी 2 आहेत, 2च कॉमन आहेत. कुठले कुठले, 5-3 and 6-2. 5-3 and 6-2, these are common A intersection B. Probability of B, there are total 15 elements, so 15/36, so this is equal to 2/50. म्हणजे हा बघायचा दुसरा अँगल, हा बाय डेफिनेशन आणि बाय हा कन्सेप्ट की प्रोबॅबिलिटी ऑफ ए गिवन बी आपण अशा पद्धतीने काढू शकतो. सो आपल्याकडं प्रोबॅबिलिटी ऑफ, म्हणजे आपण कशीच प्रोबॅबिलिटी काढलेली, सो वी हॅव प्रोबॅबिलिटी दॅट गिवन दॅट इज द नंबर ऑन फर्स्ट डाय इज ग्रेटर दॅन नंबर ऑन सेकंड डाय, हे आपल्याला दिलेली आहे. दिस इज कंडिशन. व्हेन दिस कंडिशन होल्ड्स, देन प्रोबॅबिलिटी ऑफ गेटिंग सम ऑफ नंबर ऑन फेस इज इक्वल टू 8. इट इज इक्वल टू 2/15. प्रोबॅबिलिटी ही 2/15 आहे. तर अशा पद्धतीने ही एक्झाम्पल्स आहेत की आपल्याला ह्या एक्झाम्पल्स मधून कळू शकते की कसं काय करायचं ते. तर दुसरं एक्झाम्पल असं आहे, नंबर ऑन वन ऑफ द डाय शोज 3. वन ऑफ डाय show 3 and B, sum of number on face is 8. Sum on number on face is 8. म्हणजे आपल्याला दिलेलं आहे, so we have to find the probability that number on one of the die shows 3 given sum of the number on faces is 8. So B, here our sample space restricted to sum is 8. So sum is 8. So this is equal to 2 6 3 5 4 4 5 3 6 2. So sum is equal to 8. So for that case, we have total 1, 2, 3, 4, 5. There are total 5. So samples were restricted to 5. And one of the die shows 3. One of the die shows 3, 1 and 2. 3, 5, 5, 3. So this is equal to 2 by 5. This probability is 2 by 5. And if we want to see intersection, so 1, 3, 2, 3 by using definition, 3, 1, 2, 3, 6, and 4, 3, 5, 3, and 6, 3. So these are the possible cases in which one die shows 3. मग आपल्याला ही प्रोबॅबिलिटी बघायची असेल तर प्रोबॅबिलिटी ऑफ ए इंटरसेक्शन बी डिवायडेड बाय प्रोबॅबिलिटी ऑफ बी अँड दिस इज इक्वल टू ए इंटरसेक्शन बी. ए आणि बी मध्ये कॉमन इंटरसेक्शन दोनच पॉइंट आहेत, 3 5 आणि 5 3. सो दिस इज 2 by 36 and this is a 5 by 36. b is equal to, so this is equal to 2 by 5. अशा पद्धतीने आपल्याला ही गणित सोडवायची आहेत. तर याच्यात काही डाऊट्स असले तर विचारा, काही डाऊट असतील तर विचारा.